Now we need to talk about binary covalent compounds. So this is type 3 binary compounds. So in order to name these types of compounds, first the element in the formula is named using the full element name. Okay. The second element in the compound is named as if it were an anion. And we use prefixes to denote the number of atoms present. So that's table 2.6 in your textbook. And one of the prefixes, mono, means one. It's never used for naming the first element. So an example of this, here we have CO, so we have one carbon atom and one oxygen atom. So we call this carbon monoxide. So mono means one, but we don't put mono in front of carbon. So we never use mono if there's only one. We would only put a prefix in front of carbon if there was more than one carbon. Okay, so here is table 2.6. So these are the prefixes that we use to indicate the number of atoms in chemical names. So we're going to look at some examples using a bunch of different compounds that contain nitrogen and oxygen. Okay, so here we have 2 nitrogens and 1 oxygen. So we have dinitrogen, so we just use the full element name. And then remember, we name the second element as if it were an anion. So dinitrogen monoxide. So di means 2, mono means 1. Okay. Now this next one, remember we never use mono if the first element has only one atom. So here we just call it nitrogen, and we have 1 oxygen, so we need to use mono oxygen monoxide. Next one, still we're not going to use mono for the first atom because we only have 1. So nitrogen dioxide. Next example, now we have 2 nitrogens and 3 oxygens. So we're going to call it dinitrogen. We use the full element name for the first atom, and then the second atom we name as if it were an anion. So remember that's using the root of the word, or the root of the element, and adding IDE. So we have 3 oxygens, so we're going to call this trioxide. Tri means 3. Okay. Last one here. Again, we have 2 nitrogens, so dinitrogen. Oxygen, we have 5, so 5 is penta. Pentaoxide. Okay. So remember the rules for these covalent compounds are use the prefixes to denote how many atoms you have. The first atom in your compound is always named with the full element name, and then you use the prefix if it's anything other than 1. Okay, so 2 through 10 or higher, you would need to use the prefix for the first atom. Second atom is named as if it were an anion. So remember, anions are named by using the root of the element and adding IDE. Okay, so those are the rules for naming compounds. Okay, so the first one, we have 1 atom of phosphorus. So phosphorus, there's no mono. Since we only have 1, we don't use the prefix phosphorus. And then we have 5 chlorine atoms. So penta is 5 chloride. Next one is still phosphorus, and we only have 1. So phosphorus, we have 3 chlorine atoms, trichloride. Our next example, we have 1 sulfur, so that's just going to be sulfur. And then we have 2 oxygens, so dioxide. Alright. So let's look at a few more examples that you guys can practice. You can pause the video, write these down, practice them, and then we will go over them. So the 3 formulas I'm writing down now: SF6, SO3, and CO2. So go ahead and try those, and then we will talk about it. Okay, hopefully you got those 3 examples. So the first one is sulfur. Again, we only have 1 atom, so we don't need mono. Sulfur, and then we have 6 fluorines. So if you look back at your prefix table, the prefix for 6 is hexa, and then it's fluorine, so fluoride. Sulfur hexafluoride. Sulfur, again, for the second one, we have 3 oxygens, so trioxide. Alright. CO2, carbon. Again, we only have 1 atom, so we don't need to name it. Carbon, 2 oxygens, dioxide. Alright. So sulfur hexafluoride, sulfur trioxide, and carbon dioxide. Alright, so the last, or the next slide, shows a flowchart on how to name things, okay? So you need to look at the compound and say, is it a binary compound or not? So a binary compound, remember, is composed of 2 different elements. So you say yes, right? Is there a metal present? No, it's type 3, so you use prefixes. If there is, then you need to determine if the metal forms more than 1 cation. So that's this step here. If it does, then it's type 2, and you need to use a Roman numeral to show the charge. If no, then you use the element name for the cation. Okay. The last thing that we're going to talk about is naming acids. So acids is something that we're going to cover way down the line, but I want you guys to be able to recognize what an acid is if you're given it in a formula and how you would name it. Okay, so an acid is a molecule where 1 or more H plus ions are attached to an anion. So if the anion name ends in "ide", so that's all of the anions except for the polyatomic anions, then the acid is named with the prefix hydro. And the suffix replaces "ide". So the suffix that you would use in this case is "ic". Okay, so here we have HCl, and it starts hydro is the prefix that we use, and the element name is chlorine, which is the anion, so we need to drop the "ide" and add "ic". So hydrochloric acid, HCl. If the anion contains oxygen, so if the anion ends in "ate", the suffix "ic" is added to the root name. So here we have SO4, which is one of our polyatomic ions, and it's called sulfate, so that ends in ATE, and that is then replaced with "ic", so now it's sulfuric acid. Right? Now, if the anion ends in "ite," so then we need to replace "ite" by "us," so OUS. So here, again, we have one of our polyatomic anions, SO3. It's called sulfite. So we replace the "ite" with OUS. So this is known as sulfurous acid. Okay. So now we can look at a flowchart for naming acids. So if it is an anion that contains oxygen, if you say no, then you add hydro plus the anion root and ic. So hydro, the anion root, ic acid. So hydrochloric acid, hydrofluoric acid, things like that. Alright, if it does contain oxygen, then you need to check the ending of the anion. So you take the anion or the element root and add OUS if the anion ends in "ite," and if it ends in "ate," then you take the anion or the element root and add "ic" acid. Okay, so that is the end of the lecture material for Chapter 2. Chapter 3 is on stoichiometry, so those are going to be the next videos that I'm going to upload over the next few days.